Okay, so the last section of this lesson is going to just kind of go over some different types of formal testing. And what I'm referring it to is more or less different levels of testing that can be done in a more formal manner on our programs. And we'll again begin looking at kind of the infrastructure and tools that can be used to incorporate such testing into our the programs that we're developing in this course here throughout the remainder of the week. So formal testing. So a lot of the content from this last section here was taken from the Clean Coder by Robert Martin. I highly recommend this text if you're looking for some reading over. I guess we don't have a break this semester, but maybe over the summer or just leisurely throughout the semester. More or less, what we're going to kind of do is break down our test more or less into what I'm going to look at is going to be four categories here. I'm not going to look at the exploratory test, though I'll acknowledge them here, acknowledgement. But what we'll talk about briefly here is the unit test, which are essentially going to comprise the major bulk of the test that will be executed against our program. Directly above that is going to be, sorry, I see a little thing on my, okay, cool. So that's not on the actual screen. Directly above that's going to be the component test. They'll comprise, again, a large number of the actual test being used against our applications. And then with each kind of level up, the number of tests that are contributing to kind of the whole test base will go, will decrease in number, but we'll see here that if you focus on the lower level and you get a lot of things hopefully working there as you begin to bring things together, you should be able to rely on the fact that, okay, I tested at this very low level. Well, now if I bring things together, the issue should maybe be in how these things are communicating or otherwise. But we'll pull the wrapper back on that here momentarily. So next up is going to be integration testing, and then we'll finish with a brief discussion of system test. So these are the four that we'll concern ourselves with just in this discussion for the purpose of the class. We're really only going to look at unit test and component test for the most part. So what are unit tests? So these are going to be more or less written by programmers for programmers. They're going to test the system at the lowest possible level and isolated more or less whatever it is that we're testing from the more complete system. So think about where implementing some sort of function, we'd probably write a unit test for that, provide various inputs and ensure that the outputs are calculated to our expected values. What we'll see here, I believe in tomorrow's lesson is going to be test-driven development, TDD as it's frequently known. And what that's going to really encourage us to do is to write these tests before we begin writing the actual implementation code as a way to say what that code block should accomplish, as well as providing us a way to, okay, essentially all the tests would be read, and as you begin your implementation, you kind of have a roadmap, and once all of the test cases turn green, your implementation should hopefully be more or less correct. The idea here is to get as close to 100% coverage as practical. So what we're talking about with coverage is, okay, so you'll hear this terminology called the happy path, which is like the kind of typical pathway through the program. It's not necessarily going to be focused on the cases where errors could arise or exceptions could occur. It's like the normal general case where everything goes smoothly. So we'd want obviously coverage within even these small units of the happy path and then the sad path as well, or the sad paths, which are those error prone kind of pathways that could be could present through whatever sort of small unit that it is you're constructing. So the more exceptional cases, the cases where one would expect things to go wrong, the fringe cases, the edge cases, etc. The unit tests should do their best job possible. They should be written to cover both the sad the majority of the sad pass, as well as the definitely the general cases as well, the happy pass. So think those as like function level. They're very looking at pieces almost kind of autonomically. The next step up is going to be component test. These would be written against individual components of the system. So I guess for the purposes of our discussion, it could be against like a user-defined type. I know we've only talked about struct, but this could be, I don't know, ensuring that, I don't know, something we're building is working correctly. So these will be written against an individual component of the system. You could think about it as perhaps testing your class implementations, as we'll see later. I'll go ahead and just throw that word out here now because I expect you all came from either 125 or had another programming class before this. So you should have kind of a general idea what classes are. So as a component, we could kind of test the overall behaviors of the class and not necessarily each of the functions that are contributing to those behaviors. So we're going to pass input into the component. We'll gather some output from that component. We'll test to ensure that the output is correct given that input. One key thing to be here is that if a particular component interacts with other components, we're going to try to test this particular component in isolation from everything else as much as possible. And what we'll learn in later courses, particular software engineering, that mocking and test doubling techniques is one way to really isolate out a component from other potential components that are interacting with it or that it's relying on. The component tests are going to be more directed towards the happy pass and the more obvious fringe conditions. Unhappy pass tend to be covered more or less in the unit test phrase, and hopefully by the time we're integrating these things together, the kind of major pathways that we would expect to see are going to be the common use cases. Next up is going to be integration testing. So these tests only have meaning for like larger systems where the individual components are really interacting with one another. And to some extent, there's a level of coupling here where they are indeed relying upon one another to help the system accomplish whatever it is that it's been designed to do. So integration tests are going to examine the communication between groups of components in the system to test how well their assembly comes together. You can consider these plumbing tests as Robert Martin calls them in his Clean Coder textbook. It's more or less addressing questions such as, are the components adequately connected? And moreover, since they are connected, can they clearly talk with one another? So are all the pieces kind of fitting together? Are these smaller subsystems, you could say, coming together appropriately to give the illusion of this larger system? So I'm just pointing this out, written in the same environment as component test. A lot of times the framework where we're running our unit test on would be a little bit different from our integration and component test. For the purpose of this course, we're going to use the same tool. It's going to be the Catch2 framework. And there's ways to craft tests within this framework that look more like unit tests, and then others that look more like these behavioral tests in the sense of a component or integration test. Now, the last kind of level for our consideration today is going to be system tests. These tests would be executed against the entire system. So in other words, has the system been wired together correctly? Does its parts interoperate according to specification? So this is like the end result. These are, I mean, if you look at all the pieces, we tested them individually, the actual pieces contributing to a component, then we looked at the actual component, ensure that it was acting, implemented correctly. Then we looked at, okay, are these components now integrating correctly? And then finally, at the very end, it's, are the overall behaviors of the system, is everything coming together adequately? So next up, we're going to talk about test-driven development, TDD. We're also going to talk about behavior-driven design. I believe these will constitute a single lesson, or perhaps I'll break it into two. And then the final topic in this series of um, testing and debugging, if you will be how to write formal tests for your C++ program. And we'll see the utility and kind of the power that comes along with that, using this framework and how it can really be helpful uh, towards actually implementing programs that are indeed hopefully correct and it may seem like more work at the beginning, but in the end, it will definitely pay off and decrease the amount of time that you're spending developing, because your process will hopefully be enhanced significantly by incorporating these into your practice.